Hello everyone, welcome to In 5 Minutes. In this video, we are going to solve some sums based on FIR filters. So the question is, show that if Z1 is 0 of linear phase filter, then 1 by Z1 is also the 0 of that filter. Now for proving this, let us see that if h of n is impulse response of filter, then h of z would be z transform of h of n. Now we can say that by definition, for FIR filter having length capital N, h of z can be defined as summation n is equal to 0 to capital M minus 1 h of n z raised to minus n. Now z1 is 0, it is given us. So if we substitute here that h of z1 is equal to summation n is equal to 0 to capital M minus 1 h of n z1 raised to minus n is equal to 0. Now we have to show that 1 by z1 or say z1 raised to minus 1 is also 0 of h of z. So let us substitute this term. H of z1 raised to minus 1 is equivalent to summation n is equal to 0 to capital M minus 1 h of n z1 raised to minus 1 raised to minus n. Now we will cancel out these terms and it turns out to be summation n is equal to 0 to capital M minus 1 h of n z1 raised to n. Now for linear phase filter, the condition is h of n is equivalent to h of capital M minus 1 minus n. Now we will substitute this value in the previous equation. So after substituting, we get h of z1 raised to minus 1 is equivalent to summation n is equal to 0 to capital N minus 1 h of capital M minus 1 minus n z1 raised to n. Now let us substitute this term, that is m minus 1 minus n is equal to p. So n is equal to capital M minus 1 minus p. Now we will change the limits. When n is equal to 0, p is equal to capital M minus 1, and when n is equal to capital M minus 1, p is equal to 0. So after substituting, h of z1 raised to minus 1 is equal to summation p is equal to 0 to capital M minus 1 h of p into z1 raised to m minus 1 minus p. Now we will separate this term, that is m minus 1 and p. So after separating, that is summation p is equal to 0 to m minus 1 h of n z1 raised to m minus 1 into z1 raised to minus p. Now z1 raised to m minus 1 can be brought out. So h of z1 raised to minus 1 is equal to z1 raised to m minus 1 into summation p is equal to 0 to capital M minus 1 h of p into z1 raised to minus p. Now we can change the variable in summation, that is p we will substitute as n. So finally we get as h of z1 raised to minus 1 is equal to z1 raised to m minus 1 into summation n is equal to 0 to capital M minus 1 h of n z1 raised to minus n. Now we can clearly see that is h of z1 raised to minus 1 is equal to z1 raised to m minus 1, and this is the equation which is equal to 0. So it is multiplied by 0 and again it gives 0. So finally we can say that 1 by z1 is also the 0 for linear phase FIR filter. Thank you.